So hi guys, today we are going to talk about how to do face recognition in OpenCV using Python, and there will be three steps to our program. First step will be to detect the face. So given an image, we want to detect which part of that image is a face, and then second step will be to generate the labels for the training data and then training our classifier, and the third step will be to predict the face. So given an image, we want to predict whose face it is. So for that, we need to install two dependencies. One is OpenCV and second is NumPy. So I would recommend installing both via Anaconda. This way you can install the latest version of Python and it will not even mess up with your system libraries or other, you need not give any admin privileges. So let's start coding. Let's start by importing OpenCV OS and NumPy. So we'll need OS to create labels for our training data, to handle file related operations, and later on we will need NumPy to pass it to our classifier. So structure of our program is we are going to define various functions in this face recognition.py file, which are the common functionalities, and then we are going to define one more tester.py file, and this will import this file, this module, and then we are going to test out all these functions using our tester.py file. So this face detection takes up a test image which has been already loaded using imread of OpenCV, and let's convert this image to gray image because our classifier takes in a gray image because it doesn't matter whether the image is colored on black and white to detect a face. So we want to remove that distracting feature, and color underscore pgr gray is how you convert the image to gray image. And then let's name our variable as face har cascade, and now the classifier which we are going to use is called a har cascade classifier, a har classifier. So what are har classifiers? Har classifiers are basically they are trained to detect certain kind of objects. So in our case, we want a classifier which has been trained to detect faces. So we are, so to download that, we are going to go here, and this is already a pre-trained model. So har classifier, if we and if we see har cascades, you can see these files, and what we want is frontal face dot default. So this is the file. So how har cascades works is, guys, they are trained to detect certain objects, and then what we do is we superimpose lot of positive images over negative images and then try to extract certain features from it. So yes, this is the file. So download this one and put it into one of our directories. So here I have defined this folder as har cascade, and inside it I have downloaded that file har cascade frontal.default.xml. So these are huge XML files. So if you open this file, you will see a lot of features are encoded in here. These are huge XML files containing the features to detect face. So we are going to use that to detect faces. Let's give that file .xml, and now next will be, let's define one more variable, faces. Now this variable has loaded this classifier, and now we are going to call a function detect multiscale, which is going to return us the rectangle where the face is detected in that particular test image. Okay, so we are going to pass it a gray image and some other parameters. So scale factor, how do I define scale factor? Is like, if I say 1.32, that means I'm saying decrease the size of the, scale the image and decrease its size by 32%. So what happens is, while training this classifier, it was trained for some specific size of the images. So images which are bigger in size are likely to be not detected by this classifier. So what we do is essentially we try to reduce the size, we try to scale the size and rescale it so that it has more chances of getting detected by the classifier. Okay, and one more is min neighbors. So how this min neighbors works is, in case if you give min neighbors is 0, there are a lot of faces and lot of false positives will be detected by the image. So essentially you are saying that it should have at least 5 neighbors for it to be detected as a true positive. So this is the optimal value, and we'll play around with these numbers to see how they actually works. Okay, and now we are gonna return faces and the gray image. So why we are returning this gray image is that later on when we train our classifiers, it will need this gray image. So whenever we call this face detection function, it will give us the rectangle where the face is in the image and a gray image. Okay, so now let's write one more let's save this file as tester to test our function. Let's define all the modules here as well. So I'm just going to copy all these modules. Okay. And we are also going to import this file face recognition as fr to be able to use its face detection module. And let's load a test image. So cv2.imread is used to load an image, and let's give it an image. So I have given few images in test folder, so I'm going to take this neha3.jpg and it's inside test images folder. Okay, now let's say we get faces detected and a gray image by calling face detection. So fr dot face detection, and we are going to pass it this test image which have been loaded using imread. Okay, and now we are going to say okay, and let's just print how many faces were detected. So we'll just say face detected, just to know how many faces are getting detected so that we can play around with this numbers of scale factors and minimum neighbors. And then let's try to draw the rectangle around faces when we are detecting it. Faces detected. Okay, and what we will need is cv2 dot rectangle. We will give it the test image. We are giving it the normal test image and not the gray image, right? Because on that particular image we want to display the bounding boxes, so that's why we are using this function from OpenCV, rectangle. Okay, and then we need to give it xy points. Here we basically give the opposite diagonal points of the bounding box, which is going to form around the faces which we have detected. And then it will take x plus width, comma, y plus height, and we need to pass the color of the box. So I'm going to pass purple 0 0. It's your wish, you can pass any RGB color, and then optionally we can pass a thickness. So I'm going to say 5. Now we are going to show our image. So I'm going to resize it because sometimes the images can be, their resolution can be really big and you might be able to see only a small part of the image. So for that we will resize it to be able to see the complete image in case it doesn't fit our window. So we will resize it around 1000 and 700. And now we will use im show from OpenCV to show. So we'll say face detection tutorial, comma, resized image. And now let's say cv2.read key. So this means it is going to wait indefinitely until any key is pressed, okay? Or else you can give cv2.wait double equals q or any other key name in case you want to destroy all the windows on some specific keys. Okay, so let's use this tester function and run it on command line using Python. Let's see. Okay, we got an error. CV2 has no attribute. Color BGR gray. Let's see if we made any mistake here. Color underscore BGR gray. Okay, sorry guys, this is BGR2 gray. Let's check it now. Okay, we got this assertion failed. So many a times guys you might get into this kind of errors, assertion failed. In that case what I would suggest is giving the complete path of the image. So this most commonly occurs if we give this relative images, relative path name. So let's give the complete image, test images, neha.yadav.channel. Yes, it was correct. So let's give its complete path. So copy, this is path name, and let us just add it here. Let's see if it runs fine. Okay, I'm getting it in detect multiscale. Let me go and check what is happening. It could be with har cascade also, so we are going to give even its directory as a complete directory. Copy this thing and I'm going to paste it here. Let's see if the error persists. I think it is working. Okay, none of the windows got opened. CV2 has no attribute resized img. Okay, I think I have created some blunder over here. Let me check that. CV2 dot resized image. Okay, I'm sorry guys, this is im show. This should be resize. Sorry guys. Okay, let's just run and check. I think we got some more error. CV2 has no attribute wait key. Okay, what's the error? Okay, should be capital over here. Now let's check. Okay guys, yeah, we are able to detect this face, and now let's any keys and that disappears. Let's play around with this scale factor in order to see how this can basically affect. So now I'm giving it 1. Let's see what happens, how many faces gets detected. Okay, let me give it 1.2. Previously it was 1.32. Let's see how many faces now gets detected. See, two faces got detected because of that. So now let's slowly increase it to 1.3. Now let us see what happens. Okay, only one face was detected. So 1.3 is optimal scale factor value for us for this picture. And minimum neighbors, let's say minimum neighbors is 1. Let's see what happens. See how many faces were detected, how many false positives were detected. So that is why now if I give it 3, let's see what happens. Let me first close this window. Okay, yeah, min neighbor. Is the spelling incorrect? Is it min neighbors? Check it once. Okay, see, let's see how many faces got detected now. 1, 2. 2 faces got detected. So let's say now 5. 5 seems like an optimal minimum numbers of neighbors for this image. Okay, only one face was detected. That is this thing, right? So this way, guys, you can play around with this uh, scale factor and minimum neighbor arguments. Okay, so let's create another function called labels for training data to generate labels for each of the images in our training data. Because this har classifier accepts images and the label associated with it, and that label should be only integers. So how we are going to structure our training data is like this. So in this training images, I have mentioned 2 folders with id 0 and 1. So essentially 1 stores all my pictures. So I'm going to later on create a dictionary, and a dictionary is a key value pair. So 1 I'm going to name it as Neha, and 0 here I have the pictures of Priyanka Chopra. Okay guys, so let's come back here and say we are going to pass it a directory. So here in this case I'm going to pass it this directory, and what this function is going to do is it is going to go to each of the subdirectories, and it is now going to fetch all these images with their paths and mention it with their labels. So all these images will be stored with 0 label, and all these images will be stored with 1 label. Okay, okay, now we are going to use let's first create faces and their corresponding labels as face id, or you can call it labels also. So we are going to use os.walk. So a os.walk, and when we will fit it a directory, it is going to give us a path, a subdirectory, and a file name. So to handle that tuple, going to write subdir names and file names in os.walk directory, and let's say for file name in file names. Okay, we want to do for each file is we want to fetch it image path, and before that we don't want other like dxstore in Mac and other system files which starts with dot git files and all. So we are going to say something like if file name dot starts with dot, then we are going to say something like skipping system file. Okay, yeah, and we are going to continue. Okay, we don't want to continue any further this loop. Now, okay, now if this file is not a system file, what we want to extract its id, so we can use os.path dot base name. So essentially this path at first is going to give us this, and when we fed it, and this will be the subdirectories. For now it is going to give us the path of this folder. So what we want is we want to extract this base name, which is 0 or 1. So we can say something like base name, and inside it we can give us path variable. Okay, how os.walk works is, guys, it's worth reading. It goes recursively into directories. So first it will go into this directory. Now there are two subdirectories. Now it will go inside the subdirectories, and they are all the directories. And then at once it will give us, if I feed os.walk this directory, then it is going to give me these two as subdirectories, and then these all as files. Okay, so now I have fetched the id, and now let me just get the image path. Later on we will need this image path to feed it to our classifier. Start path join file name. Let's print this file name for debugging purposes. Print imagepath, okay, and now we have got the label, we have got the image path. What we need to do now is okay, for this, if you want to print id, let's print id as well. There is no confusion. Just put colon here. Okay. Let it be. Comma id. Okay. And now what we will do is we'll hit test image is equals cv2.imread, and we are going to give it this image path. So sometimes what happens is, guys, this images doesn't get loaded properly with imread. In that case, imread is going to return us none. So if it is the case, because if the image is not loaded properly, it might halt our entire program. So we need to take care of that case. So we'll say if test image is none, even then let's print image not loaded properly and continue. Next we are going to call face detection, our module. So faces, we can call it rect, faces rect, and it is going to give us a gray image. So face detection, and let's feed this test image to it. Okay, now, so guys, when training our data, we want to train our classifier using only the single person images. We cannot feed it the same image which contains two-person faces and say this is Neha or this is Priyanka. So compulsory, if I'm training it on Neha, this all should be the images of only me, and not like me taking selfie with someone else. It might confuse our classifier, right, if multiple faces are there. So in case we have any image which is having multiple faces, right, so that means this will be more than one, right? So if it is not equal to 1, what we are going to do is we are going to skip it, right? Continue. Let's write a comment here. We are assuming only single person images are being fed to classifier. Okay. Next what we are going to do is wh. So this rectangles will be returned by our faces underscore fact module, 0th entry in that. And now, so we want to extract the part of the image, and since our classifier takes only the gray images, so what we are saying is region of interest in the gray image. So we are going to crop this part from the gray image and feed this part to our classifier. We'll say gray image y to y plus w comma x to x plus h. So here we are cropping out from the gray image the part which is the face. So we are going to feed only the face part to our classifier. Okay. Now let's do is faces dot append. As I said that the trainer will only, our classifier will only take labels of type int. So we are going to convert this to int, this IDs. They will be in string format as previously. And sorry, this should be ID. So ID dot append, and faces dot append we are going to say ROI gray. Okay, ID has been appended. Now let's return this file name. Okay, return faces and face, return faces and their label. Face ID dot append. This ID has been appended. Okay guys, so this is about training, and let's go ahead and define few more functions, few more utility functions like drawing the bounding box. And let's now define another function to train our classifier on these training images. So it is going to take faces and face ID as its argument, which is going to be returned by this function labels for training data. It is going to give us the faces, the part of the face. See here we were cropping that part of the face from the image, so we are returning it. In this faces we are giving it a gray image, the part of the image which is the face of gray image. Okay, and then its label and ID. Now let's name it face recognizer, and let's load our variable inside it, classifier to recognize our face. And we are going to use lbph face recognizer for this case. So I'm not going to explain all these in details guys, you can go out and check There are different face recognition techniques like Fisher faces, LBPH. So LBPH is local binary pattern histogram, and how this works is, um, instead of looking at the entire image, what we say is, let's look at this image and we create it into 3 by 3 pixels and we write down all the pixel values, and then we say we take the central pixel and then we compare it with its surrounding pixels. So if the surrounding pixel value is lesser than the central value, we are going to assign that as 0, else other pixels will be assigned as 1. And now we are going to take it in a clockwise manner, and then we are going to form a binary pattern, and then later we'll represent this as a decimal value for the central pixel, and the image will be formed in this way, and then we are going to extract histograms from this face. And then on the last step, roughly what we do is, whenever a new image has been given, we are going to create histograms, and then we are going to give the image which is the nearest to this histogram. So roughly this is how local binary pattern histogram works. And let's now, our recognizer has been created and loaded in this variable, and let's now train it on the data that we generated. So we will give it faces, comma. Now guys, this recognizer takes in the labels as a numpy array. So we need to create this our array into a numpy array. So for that we are going to write np.array, and inside it we are going to give this face id. Okay, and then we are going to return this face recognizer. Okay, go ahead and create 2 more functions to draw the bounding box around our face and to write a text. So whose name it is, I want to display the text. So for that we are going to define 2 functions. So this function is to draw the bounding box around the detected face. So it is going to take the test image and the rectangle coordinates of the face in the image around which we are going to draw this bounding box. Okay, so if you remember from face detection, the detect multiscale is going to return us the rectangle. This is going to return us the rectangle coordinate of the face detected in this image, which we can then use to draw our rectangle. Okay, now this we are extracting all the coordinates, and now we will call rectangle function from OpenCV, and it takes a test image. I think previously we did see this in previous one when we, in our tester function when we were testing the image, we did try to create a bounding box, right? That is what we are doing. Now we are creating a separate function for it because we will need to call this one again and again. So I'm just going to copy this fast from here, that thing. Done. This function is done. Now we're going to define one more function to put the certain text on our image. So it is also going to take an image and a text and the xy coordinate where we have to put our text. So we are going to call put text function of OpenCV. Okay, and it will also take one image, one text and xy coordinates where this text should be written, and it will take a font. So I'm going to give it Hershey duplex. Hershey, I think spelling is correct, duplex 5. And 6. Okay, So this is the color, and this is, I think this is the font thickness, and this is the size of the font. Okay. Let's now go to our tester function and let's try this. Let's try to train our classifier for our training images. Okay, so I'm gonna comment out all these lines. Okay, and now let me just say I'm passing an image, I'm loading it using imread, and it is going to, we are calling face detection, which will return us the face rectangle and the gray image, and then we are going to print the face detectors, the rectangles. Okay, now what we want to do is we want to call labels for training data from our tester function. Okay, so we can say something like, okay, so our labels for training data is going to return us faces and face id. So let's say faces comma face id is equals, and here we have imported this file face recognition as fr. So fr dot, let's take this function, and it is going to take a directory where the training images are. And as we discussed previously, giving relative paths might throw some assertion errors, so we are going to, in this case we are going to give the complete path for our training images. Okay, sorry. Okay, fine. And now after that, let's pass this to our recognizer. So we are going to call this train classifier, which is going to take faces and face id returned by this labels for training data. So let's call this function train classifier. So let's say it is going to return us a face recognizer, right? It is going to create it, and then it is going to train our classifier, and it will return us the face recognizer. So let's say face recognizer equals train classifier fr dot train classifier faces comma face id. So fr dot, and let's give it this faces as arguments and face id as the argument. And so guys, here we have trained our classifier and we have generated the labels as well. Now next thing to do it is to let's go ahead and actually predict it, what the image is, right? But before it, I want to create an dictionary. So I said in this folder all my images are there. So label 1 is for me, and here in this label 0 I have created, I have added all the images of Priyanka. So we have to tell that this id belongs to who. So we are going to say, we are going to 0 belongs to Priyanka and 1 belongs to me. Okay, now we can have multiple faces in our image, right? We can have a group images. So in that case, what we are going to say is for faces in, so in this test image I can have multiple faces. So what I'm going to say is for faces in face detected. So now let's say let's take the bounding coordinates is equals, okay, let's name it face and faces detected. Okay, so this is the coordinate for single face. Now such that we have got first one of the face detected. So now what we are going to do is we are going to extract its gray part from the gray image that we generated, okay, that we got from this face detection. And now we will say is let's extract the part of the image which is face. And so what essentially we are doing here is, in a group photo, in all the face detected, we are taking the first face and we are taking its bounding coordinates, and now from our gray image which was returned by faces detected, we are going to region of interest, we are going to extract the region which is face. Okay, now this will be fed to our classifier. Now what we are going to do is, we have got here, we have trained our classifier here, so we are going to call another function called predict from OpenCV, and we are going to give it this image, okay, the part of the image which is face. And what it returns is, it returns to us a label which we have created 0 and 1, right? It is going to give us one of the labels which it has protected it, and it does return a confidence value also. So later we will use this confidence value to say whether at how much confidence we want that this value is predicted, because it is going to anyway predict any value. So confidence value of 0 means exact match, and confidence, if confidence value usually is more than 35 36, then we don't want to predict that value, because that is going to be wrong, right? It is going to predict all the values with some confidence where it is not at all confident enough, but so we will use that as a threshold value, right? Now let's print out the confidence and the label. So I'm going to say confidence, okay, confidence, and let's print the label as our label or id. And now let's say we are going to call from this face recognition this draw rectangle, which is going to create a bounding box around our image for all the images which were detected, right? So draw rect, and this draw rect, now this draw rect takes up an image and a face bounding rectangle. So we'll give it our image which is this test image, and we are going to give it this bounding face. Okay, now let's go ahead, and now it is going to return us a label, and we want to extract the label name out of that label. So in this our dictionary we are going to say name, and we are going to give it this label which was returned by our classifier after the prediction whether this face is 0 or 1. Okay, now let's say, for now we are not using confidence, we will see what happens, and then we will try to use a confidence value. Okay, detected. So this put text is taking test image text and x and y values. So I'm going to give it, this is the text, the name, okay, and this is the image, and an x and y value it needs this. So we want to, the bounding box, we want to display this at the top left corner of the bounding box. So we are going to give x and y. Okay, now this is done, guys. Now at the end we just want to show the image, right? So this is how we were showing all the images. So I'm just going to copy paste it here and just comment them out, right? So resized, we were resizing the image because it may not fit your our screen properly, and then with I am show we are showing the face, and then wait key, it is going to wait indefinitely for us to do any key press. Then after key press we want to destroy all the values. Now let's run our Let's first navigate to this directory. Okay, and let us run our tester function. Okay, we got an error. Length of faces not, let me increase it slightly. Length of faces equal to 1. Okay, we need to give columns and we forgot to give the columns. Let's go to face recognition. Which line it is? Line 32. Okay, I hope it is fine now. Okay, XY def. Okay, the same error. 149. I'm sorry guys. Yeah, we got the error as name. Okay, line number 33. Continue is not defined. Spelling mistakes. See, now our pool has no length variable of type pool. At what line we got this error? We got this error at line 18th. End tester.py. 18th in tester.py. Bool function. That's the line he's saying. If length of faces in face recognition.py line 32 in labels for training data has no length. Okay, I'm sorry guys. This is length of face detected. Okay, should be fine. It has started training and it is fetching all the images in the path and it is providing an ID to it. So as you can see, this is our training images and it is currently looking at all these images and giving all these images as label 0, and next it will go to this one and give all these images as label 1. So I have around more than 100 images in both the directories to train our classifier better. The more images you give, the better it is. And let's see, it's training, and let's see what test image we passed it. Okay, tester. Okay, it's still neha3.jpg. Okay. After training, we can directly save this data and load this classifier. So we'll do that now. We should have ran face recognizer save command to save all this data once we generate it. Okay, training, and few of the images which could not be loaded properly, so it will just give an error. It will just print out this message and not error out. So it's important to handle that condition. So until it is training it, what we can do here is after training we can save this one. So I'm going to again run this program and save this trainer. So you need not train it again and again. Once you have trained it, you can just save this data and just load this data to training data.yml. Load this data next time. So next time I did not run it again. I will just train it and save this data in this file so that I can just load this file and try to predict newer images. It is giving us the label confidence 1. Confidence is 10 and label is 1. Let's see the image. So this is the image and we have got it correctly and it has identified me correctly as Neha. Woohoo! I ran this tester file again and I have used this face recognition.save to save our training data, which you can see in this folder. Now what we are going to do is, now when we are going to run it again, we are not going to train our classifier this time. We are just going to load the saved data. So for this, let's first create a face. Let me comment out this line as well. Okay, now let's say face recognizer equals cv2 dot face dot lbph recognizer create. Let's create the recognizer here, and let's say face recognizer dot read, and we are going to give it test file. So let's give the entire path, because as we saw we were getting some errors related to assertion error, so we are going to give entire path over here for this file, and let's put that up in quotes. Yes. Now let's run it for different images. So let me just see in this test images, and it is extremely important that your training images be different than your test images, else you will not know how your algorithm is performing. If you have given the same image to train it, then it is going to recognize it with 100% confidence, right? So it is important that these images are different than the ones which you have used to train. So now let me give this image neha2.jpg. Let's see what does function recognize it, and this time our trainer is not gonna run, it is just going to load that file. So let's go there, let's say python register.py. Okay, we got some error, lpph recognizer underscore create. So is it not correct? lpph, as we missed face in between, face recognizer underscore create. Okay, let's see it runs successfully. Yes, but this time 3 faces got detected. You can see 3 faces got detected, and it is indeed true. It is a picture of Lord Shiva and Goddess Parvati, and their faces also got detected. But in this case, since we did not train our classifier for that, it is just predicting it with some confidence, Priyanka and Priyanka. So let's see with what confidence, 102 and 78. So this is the place where I would like to introduce the value of confidence. So if it sees any unrecognized face, it should not print it. So what I'm going to say is, if the confidence that we got here is lesser than 37, then I would say don't print. Okay, if confidence is greater than 37, I'm going to continue this loop. Okay, and if not, so here actually confidence of 0 means it's the exact match. So here lesser value means more confidence and more that picture has matched. So a higher value of confidence would mean that it was not able to detect it properly, there was not suitable match. Okay, so don't get confused with these high values. Now let us run the same image and let's see what happens. Now this time it should not show any labels, right? Because they were more than 100, so it is just detecting this face and not showing any label, and here it is showing label, which is correct. Let's give it some another picture, and this time let's give it Priyanka's picture. So I'm gonna take her picture. Let's take this p4.jpg. Okay, and let's run our function. Let's see what happens. Okay, only one image was detected with confidence 54. It was detected correctly, but the confidence was 54, more than 37. So that's why it's not showing any image. But it has detected, and even it was detected incorrectly. So let's check another image of Priyanka if it gets detected. Let me take Priyanka3.jpg. Okay, this is the problem with hard classifiers guide. They are literally kind of hard-coded features, so we have to give somewhere around 50,000 or so images for it to work correctly. Okay, let's see this. third image, what happens? Okay, one face is detected with label 1. Again, this has been detected with wrong label and with more confidence. So I'm gonna remove it and let me check another picture of Priyanka. Maybe Priyanka1.jpg. Let's see what happens. Yeah, this was detected properly. So this image of Priyanka was detected properly. And for that, this kind of blunders, we need to train our images more. Like feed it 50,000 or so images to detect it properly. And let me just use this image where I'm present with my brother. Let me just see what gets detected here. Okay, let's see. Yes, so it was detected properly, but since it was 53 the label, so it did not get here properly, so it wasn't more confident in that, but it had detected me properly. Okay, so this is how it works, guys, and I think our classifier needs more training with more images. So that's the problem with our cascades. And in our next set of videos we will talk about how do we do face recognition with TensorFlow. So they use CNNs, convolutional neural networks, and they are very good at classifying images. So if you want very accurate machine, we will see how we can achieve that with TensorFlow. Quickly about, instead we were passing here static images, right, which were saved in our drive. So if we want to take the images from our webcam and take that video from our webcam and pass it as a frame to our classifier, and then we want to detect in the video whose face it is. So in that case, what you can do easily is, first we have trained it, so we are loading this face recognizer, and this is just our array. And here what we can do is video capture. So it is going to capture the video, and then we can use this to read each of the frames in the video, and then it is going to give us a return value boolean true or false, and then it is going to give us the image, the frame it has captured. Now what, it is very simple. After this, it is the same procedure as we did in tester. We are going to pass this to face detection to detect the faces and show the images. And here this is the same thing. In each of the faces which is detected, we are going to take its region of interest where the face is, and just cut that portion from the gray image and pass it to our classifier, and then our recognizer will predict a label for it, whether this image is whose image it is based on what it was trained for, right? After that, we are just resizing and showing the name of the image. And here what we are doing is cv2.wait key equals, or what it says is this line, until q is pressed, that window will not disappear, right? After that, just don't forget to release your webcam and destroy all the windows. So let's run this program and let's see what happens. So let me just go here, video to tester.py. Yeah, so as you can see, my face is getting detected in this one. So it is taking it real time and it is detecting my face. And let me press Q to exit from here. Okay, we have exited, and as you can see, my face was detected with confidence 1 at all the places. And this is how you run it on real time. And then there are two more scripts which I want to talk about. So sometimes what happens is, um, the scripts are of various resolutions, so you want to resize the image to a particular size. In that case, what you can do is, we have put all the images in our training folder. So to this script, just give it os.walk. As we discussed, os.walk is going to give us a path, subdirectory name and file names, and is going to do it recursively. So I've given is this training images. This is my training images folder where it has been separated based on the labels 0 and 1. So I've given it this image, and what it is going to do is, first of all, it will skip any file name which starts with dot, and then we are going to take the image path for all these images like this, and then this base name is giving us the basically this id 0 or 1. Okay, and after that we are going to load that image, and if that image wasn't loaded properly we will neglect it, else we are going to resize it using the resize function from OpenCV, and we will say 100 by 100 resolution we want to do it for this image, and we are going to store it in a new path, resized training images. So we are in whatever folder in command line in tutorial face recognition, so there it will create a resized training image folder and put all these images in 100 by 100 resolution. So let's now run this file and let's see how the images got resized. And before that guys, I'm trying to write using OpenCV's IamWrite function, and because this directory does not exist, I'm going to create this directory here. So new folder, and I'm going to give this name, and inside it I'm going to create further two more sub folders, one with 0 and another folder with 1. Right, now let's run it and see what happens. Resize images.py. Okay, it's writing. Let's see if anything got written inside it. Yes, you can see these all images are resized for resolution 100 by 100. Let's see this. So guys, lot of time we make this mistake that we are trying to create a new directory, but we just try to write it. So IamWrite is not going to create any directory. So if this directory doesn't exist, then IamWrite will not write into that directory. So if you want, you can use here os.mkdir command as well, right? So this is resized script is video to image. So if you want to create a lot of test data for face recognition, so what you can do is just sit in front of your webcam, and as we discussed in video tester, just use this video capture and read function to get the frames, and then just use IamWrite to write those frames to the screen, write those frames to the disk, and then you can simultaneously show that, resize that image and show it whatever frames you have got, right? And if this frame was somehow not loaded properly, then it will again continue, and this is going to continue forever because we gave true. It will only break when we press this key Q. Okay, now let's run it and check how it works. Python, and our file is video to image. Okay, so it is capturing a lot of my videos and it is going to write it to the my current directory. So let me press Q and let's see if it has returned. See, these many frames were detected and returned.